Hello, all my STRATS class mathematicians. Happy Monday to you guys. Sorry I can't be there for you guys today, but we're going to watch a video instead, and then you guys will do a little activity based on what we talk about in here. So you already did this warm-up, hopefully, as a group, just to kind of review the area perimeter stuff we talked about last week. Just so you know, we will be having a quick quiz on Thursday this week, which will include some of that stuff and the stuff we talked about today. So this section, we're going to be focusing on slope. So if you haven't already, you can pause here and get out your notebook and turn to a new page because you're going to want to probably jot down some of this stuff. You should have a paper passed out to you that looks kind of like this guy. So we're going to get that filled out a little bit later in the video, but you're going to want to put it in a part of your notebook like this. So we are going to be doing an activity with this section here, but make sure you paste this into your notebook on a page where the left-hand side is open. See how this back page is open in the picture I've got? And the notes that we do on the slides that I'll do in a second, just kind of write them in the gaps here outside of that page that you put in. So if you need to pause here and do that, go ahead, and then we'll move on to these two slides that are over here, or two or three. So first of all, quick review. Slope is always used, we always use m as the variable for slope. Think about that y equals mx plus b formula that you guys were taught. Slope is always rise over run. Rise over run. So you might want to write that down just as a quick reminder. And here's the formula that goes with it. We won't really be using that quite today, but it is good to remember and kind of have a refresher of what you do for that. Slope really tells us how steep a line is. So if I look at these blue lines, the slope is going to tell me what direction it's facing, depending on whether it's positive or negative, and how steep it is. The bigger the number, the steeper the slope. So if I have a slope of 1 versus a slope of 10, 10 is going to be a really, really steep slope. So it's a good way to tell that. Something else you'll want to write down is this guy. This is our slope-intercept form, aptly named because the m is the slope piece, b is the y-intercept. We're really not going to use the y-intercept today, but you're going to use this slope piece a ton. So when you're looking for slope, be looking for the piece that's attached to x. Whatever number is attached to x is the slope. And quick reminder too, if you see something, for example, like this, if I say y equals x plus 2, what's the invisible slope that's attached to x? Think about our algebra. Hopefully in your head you remember that there's really a 1 right there. And technically, if it's a whole number, we can change it to a fraction, so it's really 1 over 1. Same thing if I was to have a slope that said 2x plus 2, it's really the same as 2 over 2, because our slopes always use a fraction. So kind of be aware of those couple things. You're going to want to look for the thing that's attached to x. Now before we get into how to find that for your activity, I'm going to play a little video for you guys that I'd like you to watch. It's going to go over the difference between parallel and perpendicular lines. Something I know a lot of you guys probably remember, but it's good to get a refresher on it anyway. It's not going to hurt to see that. So, just a couple minutes.
Lines that are perpendicular on the rectangle's perimeter. Or let's break it down even simpler. They make right angles in particular.
Parallel lines never meet. Intersecting lines make these. Perpendicular lines meet at 90 degrees. Put your hands in the air with me. Parallel, intersecting, perpendicular, they're rectangular.
Now let's talk about detecting if two lines are intersecting. It's the term that we select if at any lines connect.
Parallel lines never meet. Intersecting lines make these. Perpendicular lines meet at 90 degrees. Put your hands in the air with me. Parallel, intersecting, perpendicular, they're rectangular.
When two lines will never touch, then you can tell that those two lines are parallel. Like these telephone wires up above the street. Parallel lines will never meet.
Parallel lines never meet. Intersecting lines make these. Perpendicular lines meet at 90 degrees. Put your hands in the air with me. Parallel, intersecting, perpendicular, they're rectangular.
Alright, so that was a quick clip just to remind us about what those different lines mean. Intersecting just means that the lines cross at a certain point, but nothing really special. They mentioned a lot in the video that parallel lines never meet or they never intersect. So you can see here I have the two L's in parallel in a different color. You can remember that the L's in parallel are like the lines, they don't meet. They're like two sides of a road, kind of like the video had. And then perpendicular lines intersect at exactly 90 degrees. So they look like a T or an X or kind of like an intersection on a road. Like when you come to the intersection with stoplights, that would be a 90-degree perpendicular intersection. Okay, so you might want to write those definitions down. Again, just put them kind of in the space around that picture that you put into your notes. So again, here's what your notes should look like. Okay, so paste or just tape, either way is fine. This piece of paper in there, you're probably going to have to cut the excess pieces off of here because it's a little bit big. So cut off whatever you need to. And then over here, we're going to fill in this part. It'll be for the activity you do after finishing this video. So go ahead and pause here and make your page look like mine. Turn it sideways. Divide it into 3 equal sections, parallel, perpendicular, and then neither will be a category as well. And then we're going to go through a flow chart that actually shows you how to tell what type of lines are parallel, what type are perpendicular, and which ones are neither. So there's your blank flow chart. So now we're going to start filling in our gaps. So first of all, the first thing you got to do is find the slope of each line. So the box at the top of your flow chart, that's going to go there. So go ahead and copy that in. Once you've found the slope of each line, now that really just means looking at the slope. So remember what we talked about in this one? Finding the slope literally means, oh, the number next to X, there's the slope. Got it. Okay, once you know the slope of each line, now you have to look and see, are the signs the same? So are they both positive, or are they both negative, or are they one of each? That's going to determine what you do next. Okay? If they are the same, then you're going to take this route. So yes, the signs are the same. Then you're going to ask yourself, are they the exact same number? So if they're both positive, is it both positive 2 and positive 2? Or is it positive 2 and positive 3? If it is the exact same number, then yes, they're going to be parallel. If it's not the exact same number, then it's neither parallel nor perpendicular. It's just maybe an intersecting line. Yeah, it would be an intersecting line. So that would be your other option too. Okay, and then if I go back up here, this is what happens when the signs are the same. What about if they're not the same? Okay, well then we have to ask ourselves a couple questions there as well. Let's see if I can get this box to go away. Whoops. Holy moly. Fine, we'll just do it this way. Okay, so then you have to ask yourself, are they opposite reciprocals? Now that's kind of a crazy looking question. I know some of you are probably freaking out a little bit. Not a big deal. Just break it down. Okay, what does opposite mean? Well, opposite means, are they different signs? Well, hopefully they are, because you chose the option of the signs are not the same. So one of them must be positive, one of them must be negative. So now we're going to look at, are they reciprocals of each other? In other words, if I have one that says 1/2, the reciprocal means I flip that fraction. So I switch the numbers. So is one of them 1/2 and the other one 2, or 2/1? Those would be reciprocals of each other. If they're opposite, that means one of them's negative, one of them's positive. These two things right here are opposite reciprocals. One of them's positive, one of them's negative. The fractions are flipped. That's what makes it a reciprocal. If it is yes to both of those pieces, they are perpendicular. If no, if they're not different signs or they're not reciprocals, one of those two things, then they're just neither. They're intersecting lines again, like we said before. So this is kind of a flow chart, hopefully to help you as you go through the next activity. So once you've filled in this, feel free to pause, by the way, and rewind if you need to fill in different pieces of this flow chart. But once you're done, you should have a page that looks like this, obviously not in full color like mine. You're going to cut out all of those little squares, or rectangles, whatever you want to call them, those little rounded rectangles, I guess we'll say. And you're going to figure out where they go into this chart. So based on the pictures, are they parallel? Are they perpendicular? Are they neither? So let's go through one of them just to help you out. Let's look at this guy right here. So we've got y equals 4/3x plus 9, y equals 3/4x plus 9. So let's go back to our flow chart. It says find the slope of each line. Okay, well let's look for my slope. It's the thing attached to x, so it's 4/3 and 3/4. That's the slope of each of my lines. Okay, got that part. So now I have to ask myself, are the signs the same? Are they both positive or both negative? All right, let's look at that. Well, 4/3, that's a positive. Let's write in a color I could actually see. Positive. This one is also positive, so yeah, they're the same signs. So I'm going to go down this way now. All right, so is it the exact same number? Are they both the exact same thing? Let's go back. Well, 4/3 is not the exact same thing as 3/4. It's kind of close, but they're not the same number. So the answer is no, which means they are neither. They're not parallel, they're not perpendicular, they're just an intersecting set of lines. Okay, so I'm going to cut this out and put it not in intersecting, because that's not one of our options. I'm going to put it in the neither category. Okay, so there's an example to kind of kickstart it. Finish the rest of them and get it checked by one of the teachers in the room.